Hello, good morning dear students. Welcome to interactive virtual class Nagaland once again. I hope all of you are doing well. Yes, so in today's class, we will continue with is matter around us pure. So in our yesterday's class we have discussed about mixture. We have discussed about the different types of mixture. Yes, students. So we have also discussed about solutions in our yesterday's class. Do you remember what is a solution? Yes, students. A solution is a homogeneous mixture of two or more substances. Yes, we have also seen that all homogeneous mixture are solutions. We have discussed that the components present in lesser amount in solution is known as solute, and the components present in larger amount is known as solvent. Yes, we have discussed about the properties of solutions in our yesterday's class, and we have also discussed briefly on concentration of solutions. Yes, the solution having large amount of solute is said to be concentrated solutions, and the solutions which contain small amount or less amount of solute is said to have or is said to be dilute solutions. So how do we calculate the concentration of solutions? We will discuss in today's class. Okay, concentration of solutions. So how do we calculate concentration of the solutions? So the concentration of a solution is the amount of solute present in a given amount, mass or volume of a solution, okay, or the amount of solute dissolved in a given mass or volume or amount of solvent. Okay, so concentration of solution is equal to amount of solute by amount of solution. Okay, for using this formula we will calculate the concentration of solutions. So concentration of solution is equal to amount of solute by amount of solution. Or we can use alternate formula, which is amount of solute by amount of solvent. So using either this formula or this formula, we can calculate the concentration of solution. So in case of solid solute dissolved in liquid solvent, okay, taking the example of salt and water. Salt is solid, water is liquid. So here the salt is the solute and water is the solvent. So in case of solid solute and liquid solvent, okay, we can calculate the concentration of solution by using this formula, that is mass of solute by mass of solution into 100. Okay, if the solute is solid and the solvent is liquid, we will use this formula. Okay, and in case of liquid solute dissolved in the liquid solvent, okay, in case of liquid solute dissolved in liquid solvent, taking the example of water and ethyl ether, we can calculate the concentration of solution by using this formula, that is volume of solute by volume of solution into 100. Okay, so check the difference. In the first case it's this solid solute and liquid solvent. In the second case it is liquid solute and liquid solvent. Okay, so this is how we can calculate the concentration of solution. So let us solve one example. A solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. So here solution, given mass of solute or salt is given as 40 gram. Mass of solvent is given as mass of solvent or water is given 320 gram. Okay, you can ignore this one. We know that, okay, we know that mass of solution is equal to mass of solute plus mass of solvent. So by calculating, adding these two, we get mass of solution. Okay, so then we have the formula. If the solute is solid, we have the formula concentration of solution or mass percentage of solution is equal to mass of solute by mass of solution into 100. So mass of solute is 40 here, mass of solution is 360 into 100, we will get 11.1%. Okay, so the mass percentage of solution for the given solution is 11.1%. Another example we can take is a solution contains 50 ml of alcohol mixed with 150 ml of water. Calculate the concentration of this solution. So in this case we see that both solute and solvent are liquid. So concentration of solution is given by volume of solute by volume of solution. So here volume of solute is equal to 50 ml and volume of solvent water is equal to 150 ml. So volume of solution is equal to volume of solute plus volume of solvent. When we add them we get 200. Then we can calculate the concentration of solution by calculating. Okay. Alright students. So we have the first question for today. Please get your rough devices ready. The question is, a solution that contains a large amount of solute is best described as. I'm giving you 30 seconds for this question. Your time starts now. A solution that contains a large amount of solute is best described as. Option A is unsaturated, option B is dilute, option C is concentrated, and option D is weak. So which of the following option best describe a solution that contains a large amount of solute? Yes, students. Alright, students, your time is up, and yes, very good. The correct answer is option C, that is concentrated. We have discussed that a solution that contains large amount of solute is concentrated solution. So here the correct answer is option C, that is concentrated. Very good, students. Now let us see here. A pond. Okay, we have a pond here. Now what are the substances present in a pond? Yes, students. The different substances present in the pond, it consists of sand, stone, water, etc. Yes. So let's take the example of water and soil. Okay, what happens when you put a spoonful of soil into water? What happens? Okay, so it is a mixture of soil and water. Pond is also a mixture of soil, stone, sand, etc. Okay, so what type of mixture is this? It is known as suspension. Okay, these are the example of suspension. So in our yesterday's class, okay, we have discussed three types of solution. The first is the beaker containing 50 ml of water and copper sulfate solution, copper sulfate powder, which gives us solution. This is the first example. In the second case, we have a beaker containing 50 ml of water and add 1 spatula full of chalk powder or wheat flour. So in the second case, we have wheat flour in water. So this type of mixture is known as suspension. Okay, this type of mixture is known as suspension. So what is suspension? Let us see. Okay, a suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Taking the example of wheat flour or atta, okay? When you mix atta with water, it does not dissolve. Yes? Or when you take sand with water, it does not dissolve. Yes, students? But it remains suspended in the water. Yes, it remains suspended in the water. So such type of mixture are known as suspension. Okay, and the particles, we can see the particles of sand or soil, yes, or wheat flour in the water. So particles of a suspension are visible to the naked eye. So let us see the properties of a suspension. Okay, taking the example of mixture of soil and water. Okay, this is the example of suspension. So keeping this example in mind, let us discuss the properties of a suspension. Okay, the first point is a suspension is a heterogeneous mixture. Okay, it is a heterogeneous mixture. It does not have the same composition throughout. The second point we have is the particles of a suspension can be seen by the naked eyes. Particle size is larger than 100 nanometer in diameter. Okay. Then the next property we have is when you pass light, okay, a beam of light passes through this suspension, the particles of suspension scatter a beam of light passing through it and make its path visible. Okay, so we have seen that in solution the particles of suspension does not scatter beam of light, but the particles of suspension scatter a beam of light passing through it. Now what happens? When you mix soil with water and leave it for some time, what happens to the soil particles? You will observe that it settles down at the bottom of the beaker. Yes. Can you filter out the soil particles from the water using filter paper? Yes, students. The solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. When it is left undisturbed, then the soil particles or the particles of the suspension will settle down. Okay. They can be separated from the mixture by the process of filtration. Okay. By using filtration method, we can separate the different components of the suspension. Taking the example of sand and water, we can separate sand and water by filtration method. Alright students, we have another question. Please get your rough devices ready. The question is, an unknown sample scatters light and is separated by a filter. The sample is most likely A or N. Okay, I'm giving you 15 seconds for this question. Your time starts now. An unknown sample scatters light and is separated by a filter, by filtration. The sample is most likely option A is compound, option B is suspension, option C is solution, and option D is element. Alright students, your time is up, and yes, very good, the correct answer is option B, that is suspension. Okay, it scatters beam of light and it can be separated by filtration. So here the correct answer is option B, that is suspension. Know this, okay, the solid substance left behind on the filter paper is called residue, and the clear liquid obtained is called filtrate. Okay, so when you mix soil with water and filter it using filter paper, okay, then you will see that some solid substance remain on the filter paper. Those substance are called residue, and you will obtain a clear liquid on another container. That clear liquid obtained is known as filtrate. Okay, so remember residue and filtrate, the difference between residue and filtrate. Now activity, okay, this will be your homework students. You can try this at home. Find out the suspensions present in your surrounding and note down the solute and solvent particles present in it. Okay, find out the suspensions present in your surroundings and note down the solute and solvent particles present in it. Alright students, here we have jelly. Okay, have you ever seen a jelly? Yes students, right, we have all seen. Yes, and we have toothpaste. If you have not seen jelly, then toothpaste, we have seen toothpaste, which we use it to brush our teeth every day. Yes. The next example we have here is paint. Okay, the paint that we use for painting our homes, buildings, okay, and for other various purposes. So these are the three examples. What type of mixtures are these? Any guesses there, students? Jelly, toothpaste, and paint. What type of mixtures are these? Yes, students. We have another example, that is milk. Okay. Now, when you look at this, these examples, these mixtures are different from solution and suspension. Yes, we have discussed about the properties of solution and suspension so far. When we look at these examples, we see that these are different from solutions and suspension. So what type of mixtures are these? Yes, students, very good. They are known as colloidal solution or colloids. Okay, so this is another type of mixture. So here we have the third case. Take a beaker containing 50 ml of water and add few drops of milk or ink. Okay, so we have milk in water. This is the third type of mixture that we will discuss. Milk in water is an example of colloidal solution or colloids. Okay, but before we proceed further, let us answer one more question. Please get your rough devices ready, students. The question is, in filtration, what name is used to describe the solid left in the filter paper? Okay, I'm giving you 15 seconds for this question. Your time starts now. In filtration, what name is used to describe the solid left in the filter paper? Option A is filtrate, option B is residue, option C is distillate, and option D is precipitate. So which of the following option is the correct answer? Alright students, yes, your time is up and excellent. The correct answer here is option B, that is residue. The correct answer here is option B, that is residue. Very good students. Now let us see. So what are these colloidal solution? We have seen some examples. Yes, like jelly, toothpaste, paints, milk. So what is a colloidal solution? So the particles of colloid are uniformly spread throughout. Okay. So when you look at the milk, okay, you will see that the particles of the colloid are uniformly spread throughout the solution. Due to the relatively smaller size of particles as compared to that of a suspension, the mixture appears to be homogeneous. Okay, the mixture or the colloidal solution appears to be homogeneous because of the smaller size of particles as in actual a colloidal solution is a heterogeneous mixture, although it appears to be a homogeneous mixture because of the small size of its particles. Examples of colloidal solutions include cloud, gemstone, face cream, milk, ink, blood, jelly, and solutions of synthetic detergents and etc. Okay. Now let us see the properties of colloids. What are the properties of colloids? So taking the example, keeping in mind that paints or milk are the examples of colloids or colloidal solution, let us see the properties. So colloids are heterogeneous mixtures, meaning they do not have the same composition throughout the solution. Okay. Example, milk. Okay, let us hear the particles of milk. Okay, when you look at the particles of milk, you will see that you can see small particles of milk, right? So particles of colloids are relatively smaller than the particles of suspension. Hence we cannot see the particles of colloid with naked eyes. You will see that when you look at the milk, okay, you will only see white color, but you cannot see the separate particles of milk. Yes, so particles of colloids are relatively smaller than the particles of suspension. Hence we cannot see the particles of colloid with naked eyes. Okay. What about splitting or scattering of beam of light? Colloids are colloids particles are big enough to scatter a beam of light passing through it and make its path visible. Okay, so colloids particles are also are small, are small to be visible to our naked eyes, but they are big enough to scatter a beam of light passing through it and make its path visible. Okay, so when you pass light through a milk solution, then you will see that it scatters a beam of light. Tyndall effect. What is Tyndall effect? So let us see. Colloidal particles can easily scatter a beam of light. This scattering of beam of light by the colloidal particles is known as Tyndall effect. Remember this term, okay, students? Colloidal particles can easily scatter a beam of visible light, and this scattering of beam of light by colloidal particles is called the Tyndall effect. Alright, students, we have another question. Please get your rough devices ready. The question is, which of the following will show the Tyndall effect? Okay. Option A is salt solution, option B is milk, option C is copper sulfate solution, and option D is all of the above. So I'm giving you 15 seconds for this question. Your time starts now. Yes, students, which of the following will show the Tyndall effect? Option A is salt solution. Option B is milk. Option C is copper sulfate solution. Option D is all of the above. Alright students, your time is up. So here when we look at this option, salt solution, it is a solution. Copper sulfate solution, it is a solution. Okay. The Tyndall effect is caused by the scattering of beam of light by colloidal particles. So both these are solution. So this cannot show Tyndall effect. However, milk is a colloidal solution, or it is a colloid, so its particles will show the Tyndall effect. So here the correct answer is option B, that is milk. Okay. Alright students, so these are some of the examples of Tyndall effect. When you walk through the deep forest, okay, you will see such beam of light. Yes, or in the clouds, or underwater, or in a room filled with smoke, okay, you will see this light rays. This is due to Tyndall effect. This is the Tyndall effect, and this is caused by the splitting of visible light by the colloidal particles present in the atmosphere, okay, by the colloidal particles present in the cloud in the second case, and by the colloidal particles present in the water. So these are some examples of Tyndall effect. Okay. Now let us see the next property of colloidal solution or colloids. They do not settle when left undisturbed. That is, a colloid is quite stable. Okay, so milk, okay, even when you left it undisturbed for a very long time, you will see that the particles of the milk will not settle down. This is because, or it means that a colloid is stable. Okay. Now, when you try to filter it, will you be able to filter the milk? The solute particles cannot be separated easily by the filtration method. Okay, it cannot be separated easily by the filtration method. So solution, let us see. Solution, we have seen that solution is equal to solvent plus solute, right? So in colloids or in colloidal solution, we have dispersed medium and dispersed phase. Okay. In solution, we have solvent plus solute. In colloids, we'll have dispersed medium plus dispersed phase. Okay. So what are these dispersed medium and dispersed phase? The component of a colloidal solution, the components of a colloidal solution are the dispersed phase and the dispersion medium. Okay, the components of a colloidal solution are the dispersed phase and the dispersion medium. So these are the two components of colloidal solution. The solute-like component or the dispersed particles in a colloid form the dispersed phase. Okay, the solute-like components or the dispersed particles in colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersion medium. So when we relate this dispersed phase is solute-like and dispersion medium is the solvent-like. Okay, so these are the two components of colloidal solution. Alright students, we have another question. Please get your rough devices ready. The question is, which of the following is not a component of colloidal solution? Okay. Option A is dispersion. Option B is dispersion media. Option C is dispersed phase. Option D is all of this. So I'm giving you 30 seconds for this question. Your time starts now. Yes, students. Which of the following is not a component of colloidal solution? Option A is dispersion. Option B is dispersion media. Option C is dispersed phase. Option D is all of this. So which of the following is not a component of colloidal solution? Remember students, we have only two components in colloidal solution. Alright students, your time is up. And yes, we know that dispersed phase is a component of colloidal solution. It is a solute-like component. And dispersion medium or dispersion media is a component of colloidal solution. It is the solvent-like. Okay, so these are the B and C are the component of colloidal solution. So here not a component of colloidal solution is option A, so the correct answer will be option A, that is dispersion. Okay, dispersion is not a component of colloidal solution. Alright students, let us see activity. We have an activity. Okay, check out the Tyndall effect for the solutions given below and note down whether the solutions show Tyndall effect or not. Okay, so this will be your homework. Okay, take shaving cream, okay, and check whether they show Tyndall effect or not. Another example is jelly. Then another example is sugar solution. Then we have soap solution. So taking these solutions, check which of the following will show Tyndall effect and which of the following solution will not show Tyndall effect. Another solution is copper sulfate solution. So taking these solutions, check out whether which of the following will show Tyndall effect and which of the following will not show Tyndall effect. Common examples of colloids. Okay, let us see some common example of colloids. So in colloids we have the dispersed phase, dispersing medium, type and example. So let us see one by one. The first is when the dispersed phase is liquid, dispersion medium is gas. Okay, example, this type of colloids is known as aerosol. Okay, when the dispersed phase is liquid and dispersion medium is gas, this type of colloids is known as aerosol. Some examples of aerosol includes fog, clouds and mist. Okay, then the second we have when the dispersed phase is solid and dispersing medium is gas. This type of colloids is also known as aerosol. Some of the examples include smoke, automobile exhaust. Okay. The next we have is when the dispersed phase is gas, okay, and the dispersing medium is also gas. This type of colloids is known as foam. An example of foam is shaving cream. Okay. Another type is when the dispersed phase is liquid and dispersion medium is liquid. This type of colloid is known as emulsion, and some of the examples include milk and face cream. The next we have is if the dispersed phase is solid and dispersion medium is liquid. This type of colloids is known as sol, and some of the example includes milk of magnesia and mud. Okay. The next we have is if the dispersed phase is gas and the dispersion medium is solid. This type of colloids is known as foam, and some of the example includes foam, rubber, sponge and pumice. Another type we have is if the dispersed phase is liquid and the dispersion medium is solid. This type of colloids is known as gel, and some of the examples include jelly, cheese and butter. And another type we have is if the dispersed phase is solid and the dispersion medium is also solid. This type of colloids is known as solid sol. Okay, and some of the examples include colored gemstones and milky glass. So here we see some common examples of colloids. Okay, common examples of colloids. So then you try to remember the state of the dispersed phase, the state of the medium, dispersion medium, the name of the type of the colloids, and the examples given for each type of colloidal solution or for each type of colloids. Okay. Alright students, so in today's class we have discussed about concentration of solution, how to calculate concentration of solution or how to calculate the mass percentage. Yes, we have seen that if the solute is solid and the solvent is liquid, then we will use the formula mass of solute by mass of solvent into 100, and in case of liquid solvent and liquid solute, we will use volume of solute by volume of solution into 100. We have also discussed about what is suspension. Yes students, what is suspension? A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended. okay, but remain suspended throughout the medium. Okay, we have seen the properties of suspension. We have seen that one example is one example of suspension is mixture of soil and water. Keep that in mind. Okay, example of suspension is mixture of soil and water. Now keeping in mind this mixture of soil and water, we will list out the properties of suspension. The first is that a suspension is a heterogeneous mixture. They do not have the same composition throughout the medium. The second is the particles of suspension can be seen by our naked eyes. We have also seen that the particles of suspension can scatter a beam of light passing through it and make its path visible. The fourth property of suspension is the solute particles, it settles down when left undisturbed. Hence, we can say that suspension is unstable. Okay, we have seen that the particles of the suspension can be easily separated by filtration method, and the solid residue present on the filter paper while filtering or during the filtration method, the solid residue present or the solid particles present on the filter paper is called residue, and the clear liquid obtained is known as filtrate. Okay, then we have also discussed about colloids or colloidal solution, taking the example of milk, okay, or taking the example of jelly or toothpaste. Okay, we have discussed colloidal solution. So what are colloidal solution? In colloidal solution, the particles of a colloid are uniformly spread throughout the solution. Okay, and because of the small particles of colloids, this mixture appears to be homogeneous, but in actual, colloidal solution is a heterogeneous mixture. Okay, now let us see the properties of colloids. Keeping in mind the example that is milk, okay, colloids are heterogeneous mixture. The first property. The second property is that particles of colloids are relatively smaller than the particles of suspension. Hence, we cannot see the particles of colloids with our naked eyes. Okay, but the third property is that colloids particles are small. That's why they are not visible to our naked eyes, but they are big enough to scatter a beam of light passing through it and make its path visible. We have also seen that colloidal particles, they show Tyndall effect. Yes, they scatter a beam of light passing through it. And this Tyndall effect, what is Tyndall effect? Tyndall effect is the scattering of beam of light by the colloidal particles. Okay. The next point we have is the particles of the colloids or the colloidal particles that do not settle down even when left undisturbed. So hence we can say that colloidal solution or colloids are stable. Okay. This the next point is the solute particles. Okay, the colloidal particles cannot be easily separated by filtration method. We have also seen the different components of colloidal solution. The component of colloidal solutions are the dispersed phase and the dispersing medium. The solute-like component or the dispersed particle is called the dispersed phase, and the solvent-like, okay, or the component in which the dispersed phase is suspended is known as the dispersion medium. We have also seen the different examples of colloids along with the dispersed phase, dispersion medium, and the type of colloids along with examples. So I hope you are clear with what we have discussed today. Yes, students. So this leads us to the last question for today. Please get your rough devices ready and respond to this question. The question is, how do you feel about today's class? Option A is happy, option B is quite good, option C is satisfactory, and option D is confused. So I'm giving you 25 seconds to respond to this question. Your time starts now. Yes, students, how do you feel about today's class? Yes, students. Alright, students, your time is up. Thank you so much for your response and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.